Uh, okay. Do you hear me now? I don't know why, but it reset it for some reason. Yeah. Okay. Sorry about that. All right. So today we are going to talk about two very interesting design patterns, Singleton and Facade, and they're very interesting for one uh, interesting reason, because we use them without knowing. We use them quite often, I would say, maybe even more often than other patterns. And the way we use them, we might not even realize it. So today I'll try to explain how can we use something without knowing, how do we use them in .NET Core, and why is it uh, not needed to make your own singleton these days, and how you can use it out of the box in .NET Core or in general through dependency injection, and how or why we nearly always have a facade in our applications. So the first pattern we'll talk about is singleton. You might hear that singletons are going extinct, that it's an anti-pattern, that you shouldn't be using it. But the truth is actually quite different. There is nothing absolute, and so this rule is not absolute as well. Singleton essentially is what problem does singleton solve? It solves the problem of a static class when we want to have global access to something. So what problem does a static class have? It has a problem of having everything in memory, making the need of making everything static, unable to implement an interface. So there are plenty of problems with a static class. It's not very object oriented, yet singleton makes it object oriented. Anyways, the only reason you would want to use singleton is when you want to ever have a single instance of something. So a single instance of something could make sense in a scenario when, let's say, you are creating a configuration for your application. Let's say you have a sound manager that persists throughout scenes, that you can access throughout scenes. Let's say in Unity game engine, when you move from one scene to another, you essentially create a whole bunch of objects, a container object scene that has references to other objects. But singleton, it can persist throughout the scenes and you can access it globally. So it's useful for managing sound, other settings, and in general, it's quite good for performance reasons. So singleton, how do you implement something that has a single instance, that you cannot create more than one instance and that you can have global access? Well, the answer is by having an instance to yourself. So singleton has an instance to itself. It has no public constructor because we don't want to enable others accessing it, and it's usually lazy loaded, meaning which that a singleton can be a heavy thing. Like your application could be quite massive chunk of data, and you might not always need to access it throughout the whole application. So you might as well simply load it when you need it and don't if you don't need it. An application of singleton, though this is more an old way, would be a logger. Back in the days, you would have a static logger that you could use throughout the application. It works. However, these days we have slightly better ways of doing it, which is which is having a generic logger that we inject and not a global one. Makes it more testable, also gives us more context to what is being logged. Anyways, this is a perfectly valid scenario for a singleton, at least a decade ago, where you could call logging service from anywhere in the application. So your logging service simply gives you a logger. I think in Java you have something like that. It's not called logging service, it's called logger manager. And it resolves a logger dynamically when you ask for it. Singleton, the implementation of it in C# is quite simple. Basically, the most easy singleton you can make in C# is by simply having a getter that has an initial value that is being assigned upon initialization. So in this scenario, when you access instance, you will always have this simple singleton created. And if I access it again, it will be the same simple singleton created. And since my constructor is private, I will only be able to access a single instance. The problem with this code is that it's not lazy loaded. Like the singleton is always there. A slightly what the hell is this? I made a poo-poo in code. Sorry about that. Right. Oh no, I didn't. Never mind. I didn't make a doo-doo. Okay, all good. So an actual lazy loaded singleton is something that utilizes lazy data structure in C#. So basically lazy data structure in C# means that only when you say lazy.value, it actually initializes the thing. So for something that is heavy, that has lots of properties, that's not worth initializing all the time, it's worth using lazy data structure. Nothing special with it. It's just something you could also make very simple yourself, checking if something is initialized and then initialize it if it's not. But it's thread safe as well out of the box, so you don't need to care about things like that. So yeah, lazy is a good way of initializing something lazily. And for singleton, it's the way to go. So if you want a proper optimal singleton in .NET, this is the piece of code you would write. Now think about what we just did and think about, ask yourself, what problem are we solving? Are we solving any business problem in the first place? And the answer is no. We're actually just building infrastructure so far so that we could have an instance, a class that has an instance to itself. So we are violating single responsibility principle right away by default with singleton because we're building infrastructure, and it is infrastructure on top of something that business needs. So it is not single responsibility compliant, and it's not thread safe by default. This implementation is thread safe. This is also thread safe, but you can derail it quite easily and make it not thread safe if you're not careful. Let's say if I try to make it lazy loaded without this and write it manually without the lazy data structure, I might derail it horribly. And you will see a code example where you might think it's accessed once, but it's actually accessed multiple times. However, I just took a dump on Singleton with this slide, saying that it's not thread safe by default, so it's risky implementation and it violates single responsibility principles. So you might wonder, why the hell would I want a Singleton? However, they are not that bad, to be honest. And I mean, there is a point to have a single instance of something throughout your application. And actually, the infrastructure stuff of lifetime of our instances is managed by dependency injection containers in a version of control containers. So in .NET Core, you would do it through iServices collection, and iServices collection allows us to add singleton. So we register a dependency as a singleton. It's as simple as that. So our to-do service is registered as a singleton. And now we can access it from wherever we want. Well, as long as we inject it. A single instance will be created. If you want to learn more about dependency injection, there are plenty of tutorials online, and specifically chapter 5, last lesson of chapter 5 was about it. And of course, in .NET Core, we inject options in order to get configuration. So if I inject iOptions to do config like this, actually by modifying its properties, I'm still modifying the same options value, because options is a singleton by default, and actually is a good choice to make it a singleton by default. But for that reason, you should actually always have read-only properties, because you risk doing something ridiculous as this. So iOptions are constantly used throughout .NET Core, and therefore we always use singletons. We inject singletons a lot, and therefore we use singletons. Facade, the next pattern. Facade looks like this, basically a tip of an iceberg. Under the hood, we might have a ton of dependencies, a ton of complex components, but to the public, we should keep it simple and expose a simple interface. So that's the problem that Facade solves. We simplify complex structure. So imagine if you had 5 dependencies, and then the 5th dependency has dependencies to other things. And if you exposed everything, you would really complicate shit. Like, it would be hard to understand, why do you expose everything? Why do you need everything public? How do I get to what I want to use? And ask yourself, is it really necessary, or can you do better? And actually, why is the facade the pattern that we should be using more often? Well, it's because we want to keep it simple. We don't want to let everyone know what hides under the hood. We want to keep it secret, not for security reasons, but for ease of use and maintainability reasons. So instead of having an interface that talks about components, we have an interface that talks about behaviors. And it doesn't even matter that under the hood there are tens, dozens of components and dependencies. We just expose what we want to do. If I have a to-do service, I want to simply say that I can save, delete, and get to-do items. If I do a lot more in between, it doesn't matter, because my service implementation will handle that. It's a detail, but I won't expose anything publicly. And if we think about it, what happens if I expose everything publicly, and what problem does a facade pattern tackle? It's the problem of train wrecks. Consider this example, which is perfectly valid code. So if instance of foo would expose member bar, and if member bar exposed member R, if member R exposed member mar, and if member mar exposed member tar, and that is where the functionality we want lies, it would mean that we actually need to chain a lot of members to get to the functionality that we want. And this chain could be called a train wreck, because when you add dots, it looks like a train, like a wagon of a train. We don't want that. We don't do that. Don't mix this with LinQ, because with LinQ you simply query a different collection. The problem with this is that it's the same object. You're just going deeper. So we don't want to expose all this internal structure. So this is a train wreck basically. And this is, so the solution to this problem, or a design rule, is to talk only to your immediate friends. And this is called law of Demeter. We don't chain stuff, we call it immediately. If we do not call only our immediate friends, then we risk confusing people who are consuming our code. We risk people simply getting our code wrong and not understanding our intention. And I wanted to share with you some exercise about structuring UML properly. So we have this to-do service, as I said, and now we need to design it so that it's simplified. We need to put the relations correctly to the classes that we have, so that the end result is a very simple service, a to-do service. So I would start from to-do service being at the top, and these points are for to-do service. And then what does the to-do service need to do? Well, I don't really care. I just know that a logger, like I want to log all that is happening. So I will need an instance of logger in to-do service. And we actually, so let me move stuff I don't want to care about yet. So we have file logger. What other logger do we have? We have database logger. Then we have, so when I do any of these actions, I log stuff. When I want to save the to-do item, so I will need a repository. Repository is an object, like a domain service that's responsible for persistence of domain models. So I have to do repository, and that's the implementation. Then if the user has notifications enabled for created to-do items, or for reminders that the deadline for it is about to, come, I want to know, I want to be notified. I want to have a possibility to be notified. So again, I'll take this. So let's move this here. Let's move this here. Let's move this here. And lastly, I have something that tracks telemetry, like how long did my request take? I want to know so that I can optimize things better. So telemetry tracker works with telemetry object that tells when did something start and end, how long did it take, and what was being done at the time. So you might think that like I need to know about many complex things, but all I care is that I can save, delete, and get items. The rest is just a detail. So I'll do just that. These things are public. Right, so these things are public. And only the implementation will know what I need to do. How it's done, or rather what dependencies are needed. So I'll have a dependency to logger, file logger, or rather I'll have a dependency to simply logger. Next, I'll have a dependency to notification service. Boom. Then I'll have a dependency to telemetry tracker. And of course, I'll have a dependency to do item repository. And that's it. So these things that are private will be injected through constructor. So boom, boom, and boom. And the arrows now. Jesus. The arrows now. We use ilogger. Actually, we don't use it. We are depending on it. I might be, yeah, putting wrong error. Association, that's the error. So we have a dependency to logger, ilogger, iNotification service. To iTelemetry tracker. To iTodo repository. And then where is it? This is the arrow. So these are implementations for logger. This is the implementation for repository. Telemetry tracker. Email notifications, implementation of notifications. And finally, telemetry tracker creates telemetry. So it's not use, it's returns. That was something with returns. There we go. And of course, to-do service implements to-do service. It's not interface, it's a class. That's right. And that'll be it. That's our facade. Why is it great now? What benefit did we just have with designing it like this? You see, if I hide the to-do service, and if I ask someone to, pick all the functionality that's needed in order to save a to-do item, so I would then need to figure out how the hell do I get logger, how the hell do I get notification service, how do I get telemetry to track how long it took to save an item, and so on and so forth. So service facade is something that hides the complexity of what actually needs to be called in order to work with stuff. So it simplifies things significantly. I would dare to say that service, the whole term service, is just a modern way of saying facade these days. And services, especially in domain-driven design, are used all the time. They are the component that is the last thing that is called by the client. Client can be a controller, client can be UI, doesn't matter, but that's what it calls a service. So I wanted to put this diagram in the slides. Okay. Boom. Great. And if you want to see more code, you can have a look here. Now let's go to the live coding part. And I wanted to show some different implementations first of Singleton. So here you can see a basic Singleton implementation, which is basically a Singleton that is not lazily loaded, that is created once upon initialization of a class. And it works fine. However, a naive implementation of Singleton could be this. You might think that you can create Singleton as easily as this, which is, hey, I have a private static read-only instance of myself, and, well, if I'm not initialized, I'll just create myself. And you would think like, that should work. I mean, what's wrong with this? Right? However, the truth is not as simple as that. If I go here, I'll comment this out for now. If I go here, I have created some interesting code that basically says that concurrently, in parallel, I'll try to access the instance of my singleton 1,000 times. I won't do anything with it. I'll just access it 1,000 times, like this. And you might think that since I always check if it's initialized, you might think that it will actually, the constructor will actually be called once. But the truth is different. As you can see, I have called this many, many times, more than once for sure. What the hell happened? And the problem is that this code is not thread safe. The problem is that when this check is being made, and while the singleton is being initialized, it actually takes time for initializing a value. And while it's being initialized, hundreds of other threads are accessing the same piece of code. So the if check happens simultaneously, and it doesn't even make it in time being initialized. It just, spams the instance calls, and that's it, which sucks. So this is not lazy initialization. This is naive initialization that breaks if you use concurrent code. If multiple threads access this. And other variants are perfectly fine. This is the one you saw with the lazy data structure. And this is the one alternative one by just being a smartass about how .NET works. So the way static works is that it only gets initialized when you refer to it. So it only gets initialized when you refer to it. So if I delegate the initialization of singleton in a static class like this, I actually achieve something interesting. By accessing this static class from my singleton class, I actually enforce this to be hit. If I don't access nested, it won't be created. What difference would it make if instead of this I did this? You might wonder. Because I wonder too now. Instance, return instance. So we'll return instance instead. Whoops. Right. Underscore instance. You might wonder what is the difference. And let's look at the difference then. Let's go to Singleton demo and let's put a breakpoint here. And let's do nested class demo, which is doing this. And I am calling this. Right? So if I debug, you can actually see that where am I? Oh, where is my debug menu? Not step into. How do I step into the next one? I don't know. Wait, it actually stopped. Never mind. I put the breakpoint in the wrong place. Well, actually, it didn't initialize itself either. Because static constructor gets only hit when you access the class. So it's kind of lazy loaded as well. Right, so we obviously got the instance once and we created it. I would say that the only benefit this has over lazy initialization is that over the explicit lazy data structure is that in case we had static methods in this, and I'll demonstrate that. Let's say we had something like public static void, sorry, misspelled public, test doesn't do anything, right? But this will invoke actually the constructor because that's how static works. So if I do nested singleton and I say test, and I debug again, right, it does trigger static constructor, but not the normal constructor still. Makes sense. Makes sense. Right. Okay, could we make a conclusion that this is lazy? Maybe. Does the other one work lazy too then? The simple one. A bit confusing. Yep. Well, it's literally the same syntax as the other one. So this one and this one is exactly the same. That's a syntactic sugar. That's what the get equals new means, basically. This one doesn't work as we saw, and this one works the same as the others. So that is singleton. And as I mentioned, we can apply singleton pattern through configuration injection. And as you can see, I'm using console application, but it doesn't have to be web API for me to use dependency injection. I can simply use a few nugget packages. So I'm using Microsoft extensions configuration. and Microsoft extensions dependency injection. And this allows me to use iService collection. And this allows me to configure sections in configuration that I read here and inject them right here. So that's pretty cool. All right. So what's the demo like? The demo is that we do this. We build service provider, which basically means we create service collection. We configure services, which means we add the configuration. And so we get the service provider, and the demo is that we resolve the service, which is to do service, and we call test method on it. And what this does, it actually prints to console what email is and sets the email to be something different. And what that means, you might wonder, why the hell am I doing this? And actually I'm doing this to prove that iOptions is a singleton. What would it mean that I change the email to a singleton object? And the answer is that it changes it across all configurations. And a proof of that is, even though I created two different configurations right here, two different to-do services right here, you might assume that they have their own configuration values, but they actually don't. As you can see here, you have different emails, the changed email. So it's not that. That's not how it works. Both are injected as transient, meaning which they are resolved. New instances get created when I call get service. Anyways, I wanted to do something, but I forgot. Anyways, the solution to this would simply be to make config immutable. So goodbye getters, goodbye setters, I mean. And I can no longer do this. But we have a different problem. When we don't have setters, we cannot set email. So yes, it's a whole different problem. So be careful with your configuration. Having it mutable sucks. Maybe you can work around this with some attributes. I'm not sure. But the point is made. iOptions is a singleton. Be careful. And for to-do service, of course, I could implement it. So let's try to quickly do something. So it doesn't even matter. So I have ilogger. From the lowest level. So void info, string message, void warning, string message, void error, string message, and maybe not message, but exception. That's it. So that's our ilogger. To service. Next, we said we have notification service. Which basically says void notify someone in a generic way. The recipient. I am adding generic parameter because it can be any type. I don't know what type it is. For, let's say, email notification service, it could be, you know, simply a person. Probably makes sense to have a message. What do I send, you know? Oh shit. Okay. Next, one last thing that I absolutely must add is the interface for repository. To do repository. Everything should be public, of course. Anyways, public void save to do. Next, to do repository can delete by long ID. And lastly, it can get by ID. Of course, it can get all of them as well. Okay. So we have a bunch of interfaces. Let's start with the implementation of this service. So we have implementation of save, delete, get. And let's continue by injecting everything. So private read-only ilogger, private read-only I notification service for what? For string, because it's email. Private read-only I repository, and that's it. So, oh crap. Let's initialize everything from constructor. Let's make sure those interfaces along with those classes are public. And here we go. So what happens when I save? Well, let's create also the last interface, which is for telemetry. So we say void start, public, of course. We say telemetry stop. That's it. Basically, when I start, I start, you know, some timer maybe to measure how much time passed, and set the start date time. And when I stop, I set end date time. And on top of that, I basically set everything in a telemetry object. If I stop before I start, everything is 0, 0, current date and date matches. So you can deduct it's not null, but it's not very useful metric. Because you called it silly in a silly way. So last one, as I said, private, read only, whoops. Telemetry tracker, and we will also initialize this from constructor. So let's do that. What happens when I save? I say info, I say saving to do item with ID to do dot ID. Yes, please. It will be long with a getter only. Great stuff. What else happens? We basically say that we are measuring time, how long it took. So we start. Somewhere here we will end. Stop. I don't know what we do with telemetry, persist, I don't know. For now, we can simply print it. Let's make it printable. So string context public date time start. Of course, let's make it immutable. Elapsed. Whoops. Elapsed ms get. So we can actually have it really smart. We can have a private constructor of telemetry. That has everything. So let's initialize everything from constructor. I really hate that it pushes it back. But anyways, this is going to be private. And we'll have immutable object of telemetry. Let's make it quite functional. Again, working with patterns in a functional style. So public static start. So when I start telemetry, what does that mean? That means I create telemetry with context being I don't know what context it is, so we'll start at context, at some context. We say that it started now. There is no point of saying when it ended. So I say it also the same thing. Elapsed, it's 0. That's the start. And I guess not static, but we can end telemetry end, which will make it new telemetry, the same context, the same start at time, and the time will be now, and elapsed milliseconds will be the difference. Which I can actually get here instead. And take milliseconds. Total milliseconds. What is it? It's a double. Okay. No problem. Double no more. Okay, so this is not needed. And this is not needed. Makes total sense now. Kinda. This one doesn't. But okay. Alright. So we have our telemetry class in a functional way. So we stop. That's right. Telemetry tracker. Stop. Well, we just established that we probably don't even need a service for that. Because it was as simple as saying that telemetry is new. Right, we cannot create new telemetry. We need to say telemetry start, saving to do, and in the end we say telemetry stop. And I mean, which creates the final telemetry. And we print it to string. Can I generate the string properly? Nope. To string. Isn't there a code snippet for that? That's sad. Okay. Return context context elapsed ms elapsed ms. Cool. That's it. So we have our telemetry that we print, a logger that logs, and what else? And of course we have repository that saves a to-do item. That's pretty much it. So yeah, now I would need to implement those other things, also notification service for whatever reason. But yeah, you get the point. You see how many things I called under the hood, and if I didn't have a service, I would still need to call them somewhere. And if I had to call them from, let's say, a controller, or let's say event handler of an event handler of what's it called, of a form or whatever, I would need to somehow initialize those things instead of initializing just this thing. So that's a facade. It simplifies significantly what I need to do. So yeah, to summarize today's lesson, we basically learned that we use design patterns often without knowing, and we don't have to know names of patterns we use. It's useful when communicating with one another to have a vocabulary that each other understands. But what matters more is to actually understand the value they give and seek for it. So keeping things simple is something we seek. Optimizing stuff and not creating unnecessary instances is also another benefit of what we might want. So understanding of modern ways of how we achieve it is all we should care about. Lastly, before I end the lesson, I would really appreciate if you guys could traditionally write one thing you understood well in this lesson that got stuck to you, and one thing that maybe you would like to understand better. Telemetry. In the meanwhile, I'll actually add the... Oh, I deleted it. Wait, I didn't. Okay. So actually, it still makes sense to have the service. So please write that. I would appreciate it, so I understand if you understood the lesson or not. That's good. Telemetry tracker. Yeah, I can, instead of that, do this. Yeah, so we simplify what happens. Start and stop. It doesn't even matter what happens now. It's okay, as long as you understood something. So if you could say what you learned, if something new you learned, then that would be useful. deleting to do ID equals this. Good stuff. That's good. Getting to do ID equals ID. Get. Okay, return to do. Following patterns and understanding it, something I'm bad at it. Yeah, doing something that someone told you just because is worse than doing it wrong, but in the way that you understand. Because if the other person is not able to explain you why they're doing what they're doing, that means they don't understand it well. And if you both don't understand it well, then you're basically applying something that doesn't solve your problem, because you don't even understand if it is solving a problem or if it's creating a new one. So it's quite scary to do things that you don't understand. And we should be careful about it, because it might have really nasty consequences, and as opposed to solving problems, it might be creating problems when there aren't any. Oh shit. Hello, Morzel. Jesus, what am I doing? I had this issue today asking C# up or so. How do you get execution telemetry? Well, for something simple as this, I wouldn't bother. For something more complex like a controller method, you normally have, this in your pipeline injected in your container. So if I go here, you would normally have something like middleware registered in your service collection. Sorry, not in service collection. It would be configure services method. Something slightly different. Anyways, somewhere there you will have middleware configured for your pipeline of the whole ASP.NET Core. For console application, I'm not sure what's the right way, but for controller, you can have middleware, you can have action filters, etc. I could make probably an attribute that does something, before and after execution of a method. Should I bother? I could implement that if you want, but that's a different topic, I'd say. I think if you really want, you could, have telemetry telemetry tracked, something like this. You could have your own method that simply does what I did, but I wouldn't recommend. I wouldn't recommend because it's hard to refactor if you choose not to use the attribute. However, in the attribute you could have the service itself, so maybe it's not that bad. I don't know. I guess, yeah, I would choose the attribute. The aspect-oriented programming. So telemetry tracked, basically you would have telemetry attributes processor or something like that. And you know, when you execute this, you could, instead of executing each method, you could invoke these methods, but before you do that, you get the attribute itself, you check what properties it has, and based on that, in between you call, maybe no properties, but in between you call start and stop of telemetry tracker. So basically that could effectively eliminate tracking, you know, if I did this. But that would be a lot of pain in the ass to design infrastructure around that. It's basically a middleware, what we would be making. For controller, that would be easier. For console application, that's like, you know, reinventing the wheel. That's probably something someone already did, so I would just get the NuGet package in the end. You could also probably, instead of doing this, have events fired. So you could have public event handler, you know, something like method started and method ended. And you could instead, you know, delegate everything to the outside. So I could, you know, say invoke, boom. I won't care, so I'll just pass no, I don't care. But this is the idea. You could play with events instead. Like logging, telemetry is something that's absolutely optional. The main thing is that I handle it. Method started. You could play around with this, but again, I don't see much benefit nor much wrong in doing something like this. My last thing that I could potentially do that I was considering when implementing is simply having a private method. So in general, when you are refactoring stuff, you need to consider what's, you know, what is the same and what is different, right? Like what do we have matching and what do we have different? So we basically have saving to do item is different for all, but that comes from our repository. The context is basically the same for all. So I'll basically copy paste a method. So that's my what's my flow of thoughts. I'll say service act service, something like that, let's say I'll call it. And basically I'll say string message, right? Message, and I'll also pass action. What happens? So what happens? This is what happens. What happens else? Well, I start this context, I log this message. This is what happens basically. So now I can refactor my thing as such, though for my getter function it breaks because I need to get the result, so I am also not sure. Again, I could work around. Could I work around? I surely could, you know. Out to do, but this is already dirty code. No, this is silly. I could work around with this more like func that returns to do. But again, sometimes it's all like for getting all it wouldn't work, so I cannot really refactor the other one. Generic function. No, I don't think I can refactor it very well. I can refactor this and this, but not this. Anyways, let's continue to wrapping it up. Maybe I could. Oh, gee. Yeah, it's so much effort for such a little thing. Anyways, for refactoring those two methods, it would look like this. So act service, what do? I say saving item, saving to do with ID equal to do dot ID, you know. And what action, what happens actually? The action is that I say repository.save to do. That's pretty much it. And again, the benefit is so tiny that I probably wouldn't bother. Though I do reduce duplication. But getting is a completely different story. So for getting, it doesn't really work. But on second thought, I could simply make a second method, act service, that has a t result that is t result, and instead of action, it will be a func that returns a result. So here I say var result is function that does something. And in the end, I return it. So if I have get, or if I have get without ID, getting all to-dos, right? So I can just say act service slightly different. Getting all to-dos. And the second one will be simply saying repository dot get. Let's add one more method to it. Oh, we do have all the methods we need. Okay. Yeah, that's all. So it's not one, it's many. Okay. And the other one would be getting by ID. Here we go. So I guess that refactored things a bit, you know. I'm not duplicating myself horribly. I basically have actions, service actions, and service functions. And not much, like I only repeat myself twice as opposed to 4 times that I could have. So yeah, what do you think? That's quite functional. Yeah, again, we could expression body it. Actually, can't expression body this. But can we? We should be able to. What the hell? Expression body everything. Why can't I expression body this? What the hell? Great, so yeah. That's refactored version. I hope that answered the question, Marcel, if you're still looking. I think this is cleaner than middleware for my case, because it's... I mean, I don't need to do this in multiple places, and for this single place, I'd definitely say it's good enough. Anyways, the point I was leaning to is that when you have duplicate code, just take 2 parts of code and identify what's different. So whatever is different goes as an argument. In my case, a message was different, an action was different. And the rest is the same, so that goes as a body. And this pattern can be applied to pretty much everything. For more complex cases, it might not be a method, it might be an object, a class. But the point remains. Whatever is duplicate is a body. Whatever is not is an argument. So yeah, Singleton and Facade, the 2 patterns we're using without realizing it. It's not a bad thing, just it's nice being aware because we can easier communicate with one another. So thank you all for watching and see you in the next lesson. Not sure what will it be about, but another couple or 3 patterns that we will cover. So see you in a week, I think. Good night.